Hi guys, my name is Hamza Abu Zaid, and today I'm gonna be doing or explaining my math project, which is about proof that there are infinite many prime numbers. So all of us are probably a little bit familiar with prime numbers, and maybe none of us have ever thought if we have infinite amount of prime numbers or not, but we're gonna try to prove it today and see if we actually have a set amount of prime numbers or we have an infinite amount of prime numbers. So first thing I want to do is understand what prime numbers are. So prime numbers are, some people might think they are only odd numbers, which is false. So a prime number is any number that divides by only itself or 1 to give us an answer that is like not a fraction. So let's take 3 for an example. We can only divide it by 3, which will give us 1, or we can only divide it by 1, which will give us 3. Any other number, if we try to divide it by that, it's going to end up giving us a fraction. And going to the next slide, the definition that I have on here is a prime number is any number greater than 1 that can only be divided by itself and 1. And I have some examples of prime numbers over here. We have 2, 3, 11, 13, 31, 37, 41, and you can keep going on and on and on and on. But as I said before, if some people have the misconception or maybe they didn't think about it, that is to a prime number, it is because it can only be divided by itself, and it can only be divided by itself or 1, and it's greater than 1. So now, how would we prove that we actually have an infinite amount of numbers or prime numbers? So, someone could say that we can keep on going on and on and on. As you can see over here, I stopped at 41. Someone could say if you can keep going, you're gonna find 43, 47, 50, etc. That if you keep going to infinity, you're gonna keep finding prime numbers, and that is not wrong. But someone else could say that you just didn't go long enough to get to a point where you ran out of prime numbers, and you can't say that they're wrong too. So how would we prove it? So the I'm gonna prove it using proof by contradiction. So what does proof by contradiction means? So proof by contradiction means is I'm gonna have a statement or say something, or I'm gonna have a set statement, and then if I ended up doing some work to prove that that statement that I have is wrong, then that means the opposite is true. So let's say I say a statement that if I walk outside my house, I'm gonna fly somehow, or levitate, or float, and then I actually walk outside my house and nothing happens because thankfully we still have gravity. And since nothing happens, that proves that the first statement I said is wrong. So the opposite is true, and that is that if I leave my house, I'm gonna stay on the ground or not float or fly. So the definition we have for that is it is a method of proving something is true by first assuming that it's false. Then, if that assumption leads to a result that does not make sense or is clearly wrong, we know the original statement must be true. So, as I said, we'll have a statement. If we did some work and then turns out that statement is wrong, then the opposite thing is true. So another example that I have over here, let's assume we're going down the road. We can only go left or right. We can't go straight back in an angle or anything. Let's assume that's like the rules of the world. And then let's say I say like my if I wanted to prove it by contradiction, I would say I can only go right. So I go down the road, I try to go right, turns out I can't. And then it works if I try to go to the left, it works out. So that means that I can go to the left only. Since I let's say these are rules of the world, you're always going to find one way that works, and you can only go left or right. Let's say I say we can only go right. Turns out it's not working. That means I only end up with the left side. So that means that I can only go left is a true statement. So if I'm trying to prove that I have an infinite amount of prime numbers, I'm gonna pick the opposite statement, which is that I have a set amount of prime numbers or a finite amount of prime numbers. That means I have a number of prime numbers that is not infinity, basically. Let's say 10 or 20 or etc. It just means that I have a set amount of prime numbers. Since this is my statement, what I have right now, I'm gonna try to do some work to prove that that statement is wrong, which in turn is gonna improve that we have an infinite amount of prime numbers. So let's see what we have in the next slide. So step one, or the first thing I'm gonna do is let's take the product of all the prime numbers we have. So since we said we have a finite amount of prime numbers or a set amount, I'm gonna take all of those prime numbers, multiply them together, and I'm also gonna add 1 to them. So as you can see over here, I have, oh, no, this is not supposed to show up. I have P1, I have P2, P3, etc., 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 Pn, which is the last number of prime numbers, and then I'm gonna add 1 to them, and I'm gonna set them all equal to P, which is a number. I decided to use P. You can use W if you like. Anything works. So after I did that, what do I want to do to prove that the statement I put is wrong? So what I'm gonna do is step 2, which is let's divide that number by any prime number. So I'm gonna divide it by P1, as you can see over here, but you can divide it by P2, you can divide it by P3, you can divide it by P4, P5, P6, P7, etc. You can divide it by anything. I decided to divide it by P1, which ends up canceling P1 on top over here and P1 on the bottom. So you're gonna end up with P2, P3, P4, etc. till Pn, which is the last P. And then you're gonna have a plus 1 over P1, which because we have an addition over here and it's a fraction, you can't just cancel the P1 on both sides. So you're gonna end up with 1 over P1. So what does that mean? So I have all my prime numbers, which are a set numbers like 3, 4, 3, 7, all of those prime numbers, 3, 7, 11. And then I have a plus 1 over P1, which is a fraction. And since P, which is the number we got from multiplying all the prime numbers, can't be divided by any prime number, I can even try to divide it by multiple prime numbers. Like if I also did P2, it's gonna go from over here, so I'm gonna end up with P3, P4, etc. And I'm gonna end up over here with plus 1 over P1 times P2. But I'm always gonna end up with a fraction no matter what prime number I pick. So what does that mean? How does that prove that our statement is false? So we have a number over here, which is P, that can't be divided by anything other than 1 or itself, and it is greater than 1. And if you guys can recall, this is also the definition of a prime number. A prime number is any number greater than 1 that can only be divided by itself and 1. So I just said in my statement that I have all the finite numbers in that equation, and turns out I have one more prime number, which shows that the statement that I said is wrong, proves that it's a wrong statement, and that the opposite of that statement, that we have an infinite amount of prime numbers, is true. And since that makes the statement that I said is false, since that makes the statement that I said at first false, and it makes that we have infinite amount of prime numbers true, so that proves that we actually have an infinite amount of prime numbers. Thank you guys so much for watching, and I hope you guys learned how to prove that you have an infinite amount of prime numbers.